Here in Chapter 7, we are kind of finishing up our just general discussion of firms to talk about costs. So, to remind us from the previous chapter, um, right, the goal of the firm is to obviously maximize profit. That profit, understood as the symbol pi, is equal to the difference between revenue and cost. The revenue part of this, well, it depends on your pricing because revenue is simply the price times the amount of stuff you sell. That pricing is determined by your competitive structure, which is why the latter chapters of this course are all about different types of competitive structures and different ways they price, which in turn tells us about their different levels of profit. The costs, though, are largely the same regardless of your competitive structure. So, in this chapter, we're simply looking at this aspect of the profit equation. So let's start first with how these costs can be understood. Is that we have both explicit cost and implicit cost. Explicit costs have something that's out of pocket, something an accountant would be rather easy to define because there's invoices, there's receipts, there's a process, there's money going out, there's some sort of accounting activity that would allow us to see what's going on. The implicit costs are a little bit harder to define. Not impossible, but they're a little bit harder. And they're important to economists because, for economists in general, something that's important are opportunity costs. And what opportunity costs do for us is they tell us about our what we could have been doing instead to make money. So, ideally speaking, a manager should be thinking like an economist and should be thinking both in terms of explicit costs as well as implicit costs in terms of what the company is doing. Now, the last bullet point here isn't entirely nice, or it's not entirely nice to accountants. I think it dismisses how unique they can be. Accountants do, to some extent, take into account implicit costs as well as implicit benefits. For those of you who are accounting students or who've taken an accounting course, you would know that we do have things such as goodwill and whatnot that aren't explicit costs, but goodwill does measure an implicit benefit that companies can earn sometimes based on the reputation that they have. Okay, so here we've got this first nature of this difference between explicit costs and implicit costs. If we wanted to talk about just economic costs in general, economic costs would be my explicit plus my implicit, which would mean that economic profit is going to equal my revenue minus my economic costs. And so we start to see these differences here with this problem that's posed. She's sent to a conference for managers, and the firm has paid her registration fee, and she gets free admission to a class on how to price different derivatives. One second. Sorry about that delay there. Okay, so let me just restart. I understand that I just did in the video, but let me just do that for my purposes. So the mayor of this firm sent her to the conference for managers, paid her registration fee. Registration fee It includes the free admission to a class and how to price options, derivatives. Um, the most attractive alternative opportunity is to attend a talk by Warren Buffett about his investment strategies. He's his good friend Charlie Munger is dead, so maybe he'll talk about that too. Anyway, the cost she'd be willing to pay is $100 a year as talk. The cost of the ticket is $40. Given that there are no other costs involved in attending either event, what is Meredith's opportunity cost of attending the derivatives talk? Well, in this case, for Meredith herself, right, her explicit costs on her side is zero, right? The company paid for it, but for her, the other kind of point of concern would be the fact that the company did pay the $40, and right, and the company might like ask her for the $40 back, right, if she doesn't go to this class on how to price options. So then the difference here would be between what she's valuing it at, $100, and the explicit cost that it's paid by the firm would be $40. So the opportunity cost of attending that derivatives lectures is $60, that difference between the two, which I think the author's in this slide. Yeah, they just spell out here what I just said. Okay, so let's start to talk about these costs. So now we have this notion of, again, the explicit costs and the implicit costs. Now let's start to talk about the different types of goods that exist. One of them being a durable good. A durable good, although they kind of just generally define it as a product that's usable for years, generally for economists it would be something greater than 5 years. That's how we typically see it, especially for households. The issue, both from a tax and an accounting perspective, is how do you account for those costs of a durable good that last over a pretty significant period of time? Well, one way to do it would be is that you allocate the initial purchase over time. And there would be some degree of depreciation, but you'd be spreading out the capital costs over time. Because one of the things that's also kind of existing in the background, once you buy this durable good, is this idea of sunk costs, that you cannot, once you spend the money, you can't recover it. And as difficult as it is, you can't look at the sunk costs when you're deciding what to do in the future. That would mean that if I spend money on a large, expensive, durable good, fixed input, you can't look at that as an opportunity cost of what I could have done instead with that money. In this case, it's just it's something that I can't go back on. The example, and now we're starting to get to a point where we can actually start to see some examples from today's news. And the one that I've never used the service, so let me just put that out there from the very beginning. But the one I was looking at here, obviously I take Ubers and I actually use Uber Eats, but I've never used Drizzly, which is they deliver alcohol. So apparently in 2021, Uber spent $1.1 billion to buy an alcohol delivery business, and now it's shutting it down. So they're probably getting critiqued here in the Wall Street Journal article. I haven't read the whole thing. But in this case, they've decided to shut it down. And in essence, the $1.1 billion, maybe they got some things for it, like customers and perhaps some different technologies. But in essence, this business that they spent money on is they're shutting it down. It's a sunk cost, what they had spent it on. Now, if we look at these short run costs as opposed to long run costs, what we would do is separate our costs into two different categories: variable cost and fixed cost. And the difference between the two of them is based on do the costs change based on production levels? If the answer is yes, then we're dealing with a variable cost. And if the answer to this question is no, then we're dealing with a fixed cost. And an example of a variable cost, a pretty simple example of that, would be something like electricity, trash services, different employee costs. Fixed costs, though, would be something like your warehouse, right? Whether your warehouse, um, whatever you do with it, the rent you pay is not determined by your amount of production. Another fixed cost would be, for instance, if you have to have like a license for operating your business, that would not be a variable cost. It would just be a cost that you bear for running your business. Or another one, going back to my airlines example, another one for airlines would simply be um, airlines have to have a certificate to fly of airworthiness, and it's very expensive. In fact, it's so expensive that for a new airline, it's actually cheaper to buy an almost failing airline to get their license as opposed to getting a new one on your own. And that's a fixed cost. It doesn't, you need the license whether you're running one flight or 1,000 flights a day. Figuring into this as well is then my marginal costs. These would consist of entirely of variable costs. So there's no fixed costs in your marginal cost. And what these do is they determine how much do my total cost change or my levels of production change. And to make life easy, we typically have the denominator, the change in production at zero, at 1. That way we can just kind of simply talk about the change in terms of the cost over 1. And then other relevant variables here would be my average fixed costs, my average variable costs, and my average costs. These are all pretty straightforward, at least mathematically, to see. My average fixed cost being my total fixed cost divided by my quantity, my average variable cost. And again, some of this you should just remember from Econ 130, hopefully, but my average variable cost being my total variable cost divided by quantity, and then my average cost being my total costs divided by my quantity. I mean, sometimes this is called average total cost, or ATC, is equaling my total cost divided by my quantity. Okay. And so this chart is important. You can expect to see this on an exam. This kind of stuff is pretty important to me. Understanding the dynamics of why the numbers are changing the way that they are. So what you see here is that for 0 output, I have 0 variable costs. You see here that the fixed costs are unchanging based on the level of quantity. That my variable costs are going up as my quantity goes up. and that my total cost equals the sum of my fixed costs and my variable costs. That my marginal cost here is my change in my variable costs over my change in quantity, or it could just be my change in total cost over my change in quantity. Average fixed cost is just my fixed cost divided by my quantity. My average variable cost would be my variable cost divided by quantity, and my average total cost would be my total cost divided by quantity. Notice here again is an important difference. These are deltas, change in variable costs or change in total costs over those changes in quantity, not my total, and total over my quantity. And I see they're just continuing it on another chart, on another slide. The math still applies to the labels I gave you there. I don't know why they didn't just show it like this. Anyway, it's important though to apply what these numbers look like to what the graphs look like. So let's talk a little bit about what these numbers look like. So if we put dollars here on the y-axis and quantity on the x-axis, you'll notice that the fixed costs are constant, as we would expect. Regardless of the level of quantity, our costs are the same, fixed costs are the same. And now our variable cost has a shape that is not constant, that in fact it begins by increasing at a decreasing rate. And then transitions to increasing at an increasing rate. That shape we also see here in the marginal cost, which is describing the slope of both the variable cost curve as well as the total cost curve, because this total cost curve, or TC, is exactly a mirror image of the variable cost curve, with the difference between these two curves being the fixed costs. And what we see here with the marginal cost is exactly this description here. It's telling us the magnitude of the slope, and we can see that the magnitude of the slope is getting smaller and smaller, and then getting larger and larger. Smaller, decreasing, and then larger, increasing. Decreasing, this part here, sorry. Getting smaller, decreasing, and then increasing, getting larger. And now what you'll notice here for the average fixed cost, its general shape is it gets closer to the origin. And that would be because if it's simply FC over Q, fixed cost over quantity, the numerator, the top, is the same, and it's always the same, and the denominator just keeps getting larger and larger. So thus it becomes smaller and smaller, the whole ratio as a whole. My average cost and average variable cost are typical U-shaped curves that go along with having average costs. And they're shaped in part by the positioning of the marginal cost curve, where again, when marginal cost is below an average, it drives the averages down. And then when marginal cost is above the average curves, it drives those curves up. Dude, I would prefer I think most people would prefer to just listen to my description I gave everyone just there rather than try to read that and make sense of that because that looks pretty confusing, if you ask me. Um, but all of this is true. Okay, so why is this the case? Why does the variable cost curve look like this? And the reason why is because variable cost it's a mirror image of total production. So here, I'm not sure why they're doing this to you here. It's a bit deceptive. Trying to see here if in the future, I print out the slides. I don't look at them usually while I'm talking. Interesting. Okay, I'm not sure why they're not showing it to you in a bit clearer fashion. Let's just draw it over here. So let's draw out my total cost function like this. Starting from a non-zero point. Oh, because it would be starting at where fixed costs are. What we'd be seeing here is that the slope is getting flatter and flatter and then steeper and steeper. The question is why is that the case? And the answer goes back to our previous chapter. Where my total production looked like this, where my workers were getting more and more productive and then less and less productive. The two are mirror images of each other because one of the significant costs for any company is its workers. And so to produce each unit of the product, at first it's getting cheaper and cheaper to produce each additional unit because my workers are really, really productive, which means that my total costs are increasing at a decreasing rate. The cost per unit is decreasing. But then eventually my workers become less and less productive, which now means my total costs are increasing at an increasing rate. So my variable costs, as well as my total costs, are a mirror image of my production for that reason. I honestly, when I look at this graph, I think the authors are trying to confuse you here. It's not entirely clear why they would just put that there and not. I mean, it's useful for other reasons, but you wouldn't leave this slide not knowing why these two graphs are related to each other. And you could understand it if you have a mathematical mind. Um, this graph would be, or this slide would be useful to you, where my marginal costs are changing, are affected by my marginal productivity levels, that my marginal costs are falling. As my marginal productivity of labor is rising. and vice versa. And you would see this here from an equation perspective. And again, all they're saying to us on this slide, again, is just that in general, our marginal, the shape of our marginal curve is affecting the shape, at least, of our average cost curve. Dude, I don't know why the author thinks it makes himself look cool just to talk about beer and wine. That's just like cheap. I don't need to seem cool with picking weird examples or I don't know, teenager or young adult examples. Okay, I'm going to pause here. So one of the things, and we've looked at it a little bit earlier when we looked at the demand and supply graph, would be we can look at what effect imposing a tax has on the firm. Remember, there's a difference between the legal incidence of the tax and the economic incidence of the tax. And we are not talking about the legal incidence. Again, in the legal, we're talking about who does the government go to? In order to get paid. That's not what we're concerned about. We're concerned about the economic incidence of the tax, which means we're looking at how much less does the firm get, and how much more do consumers pay. And all that depends on the elasticity of what we're dealing with. As just kind of one small application of that, look at something like the Social Security tax. The Social Security tax is actually paid from a legal perspective. It's paid 50% by consumers or the worker, 50% by the firm. But the reality is that if the Social Security tax didn't exist, the worker would get almost all of it just because of the nature of the inelasticity of the labor. So, in essence, we as workers are putting, we are paying the full tax on the Social Security system rather than it being something offered by employers. They're paying the tax, but in essence, they're paying us less so that they can pay the tax. In this case, we've got the specific tax and we're looking at it on the cost curves. We would see that a $10 tax is going to obviously shift up my average cost curve. It's going to shift up my marginal cost curve because now everything goes up by 10. In this case, it's going to do that. The legal incidence tells us now which curve we need to shift. And because this tax is imposed on the seller, that's going to shift these taxes. And that's what we see here. Tax is applied to the firm, and it collects it from the firm. So the legal incidence means that I'm going to be changing the cost curves here. And what that becomes then useful for us is that we can then see if we have a lump sum tax, what does that do to the cost curves? Again, not surprisingly, it's going to shift things. In this case, it's going to increase my costs by this fixed amount. But now, because it's not a specific tax, but rather a lump sum tax, now I can spread out that tax over a larger number of units, such as we go further and further to the right, the difference between the two gets smaller because that franchise tax is now spread out across more and more units. Whereas here, we had for the most part, a parallel shift between the two because it was just $10 per unit sold. Our fixed costs can go to zero in the long run, because we can get rid of things, right? We can change the way that we're doing things. So in the long run, fixed costs are zero only because everything is now a variable cost in the long run, which is why they wrote that here, that all costs in the long run are variable costs. And as we saw in the previous chapter, we can, with that production process, where we have isoquants, we can combine that with now step 2, the iso cost line. So remember, in step 1, for the production process, we were generating what isoquants look like based on the production function that exists. Now here in step 2, we're looking at the iso cost line. This isoquant is the equivalent for the consumer of the indifference curve. And in step 2, this is the equivalent of the budget constraint. And now what we're doing, our costs are simply equal to the wage rate times the number of workers plus the rental rate, which is in essence our price of capital, times the amount of capital. And so we would have an iso cost function that looks like the following, where our total costs are equal to wage times number of workers plus rental rate times amount of capital. And we can then calculate these for certain cost levels, right? So we can say, what does the iso cost function look like when I have a budget of, let's say, $20,000, right? And then we would just have these relevant functions. In a table, the way we would organize this, right, is that I have all of these various levels of my inputs, my labor and capital, right? One that's labor intensive, one that's capital intensive. So now keep in mind here, this is not reflecting production. In production, we would say that we can't produce anything if we have no labor or no capital. We had to have some mix of the two. But here, from just a simple cost perspective, we can have the two existing. And if I tell you that workers cost $10 an hour and my capital costs $20 an hour, then I can calculate various costs. In this case, all these bundles have the exact same budget of 200. Which we could then make look like this. And the slope of this is equal to, well, it's negative, but it's essentially the input that's on the x-axis, which is typically labor, over the rental rate, which is the price that we pay for capital, which is typically on the y-axis, W over R. And you'll see here that it is constant because these ratios are not changing based on how much I'm using. And we can see here, not too surprisingly, that the higher the budget allocated for things, then the greater, the further from the origin the iso cost line is. So, right, so we could imagine one way out here for a $400 budget, and so on and so forth, and then one down here for a $100 budget, because it would just mean less labor and capital that I can afford for these given things. right? Until we can just see these differences here. The X and the Y intercept reflecting again total budget divided by the wage rate, and here total budget divided by the rental rate, the price that we pay for capital. Now, the firm has three different options here. They all generate the same result, but the firm has to decide which option is it going to choose. Is it going to choose an option where it just wants the lowest ISO cost curve because it needs to meet a certain production quota? That would be your first option, right? So you would use this if you have, for instance, like a contract to deliver a certain quantity. Then you just want to find the lowest cost way of producing that production level. In terms of tangency, you could just say, in this case, my budget is what exists, and I want maximum production. In my line of business, in higher education, this is actually kind of the rule we use because essentially the legislature gives us a certain amount of money per year, and then we try to do the most with it that we can, right? And the budget doesn't really change. And in fact, we want to spend most of that money. And then we've got the last dollar rule. This would be one where you try to make it so that your marginal productivity of labor over your wage rate is equal to your marginal productivity of capital over your rental rate, meaning that you try to make it so that each input is per dollar spent is generating about the same marginal productivity. All three of these, though, generate the exact same result. I'm just going to skip over this because it's trying to stop us from getting to the cool picture. The cool picture, which is, again, I have an ISO quant line here. I have a series. So in this case here, we're doing kind of method number one, where I have a series of ISO cost line. And I'm just trying to find the cheapest way to produce 100 units, which would occur at point X right here. Presumably, if I were producing 200 units, this right here would be my cheapest way to do it. So notice here, there are three different options or two different cost levels that generate 100 units of output. Option X, which has a cost of 2,000, and options Y and Z, which cost 3,000. So to minimize cost, they're going to find that point, the lowest ISO cost curve that's just tangent to the ISO quant. Or essentially that at X, the ratio, the slope of the ISO cost line, W over R, is equal to the marginal rate of technical transformation, which is the ratio, negative ratio of the marginal productivity of labor over the marginal productivity of capital. Or to put it another way, that the slope of the ISO cost is equal to the slope of the ISO quant. And so again, you could rephrase that again as our third method here, which was that we just, the last dollar rule, we could just go straight to this kind of equation where I equate the marginal productivity per dollar spent on each of the two inputs. And we'll do some problems related to this. Okay, so if we have a production function here, which is Q So here I just did first order partial derivatives. So I took the 0.6, brought it out in front. So I multiplied 0.6 times 1.516, which gave me 0.9096 L. And then you have to subtract 1. So 0.6 minus 1 is negative 0.4. Then over here for my marginal productivity of capital, I put the 0.4 out in front. So 0.4 times 1.516 is 0.6064. K to the 0.4 minus 1, which would be negative 0.6. And now what we'd be saying is that 24 over over 0.9096 L to the negative 0.4 is equal to 8 over 0.6064 K to the negative 0.6. And then we would cross multiply. And then we would start solving for K and L. Thinking they're probably going to do that here. Yeah, and they do. So they set it up, and now they're cross multiplying, and now they've got K in terms of L. And now my method here is a little bit different. I'm not doing this A over B, K over L. My method here will generate the exact same result. A little bit slower, but it will generate the exact same result. But what's nice about this now is that now that I know that K equals 2L, what that means is that the firm, because they're using twice as many workers per capital, then let's see here. Oh no, they don't do it even further here. Then what we should see, right, if they set it up this way, what we should start to see, coming back over here, right, that cross multiplying. Sorry, let me go back to this here. 1 second here. Sorry, I was going so quickly that I made a mistake there. Now again, I would cross multiply here. And once you do that, you should get 2L equals K. Once we simplify it, it'd be a bunch of steps here to get to this point. I'll outline those steps further when we get to me describing the homework. But then again, what becomes useful for that is that what we can see here is that workers cost 3 times as much as capital. And yet capital is twice as productive as labor. So there is a difference here. Workers cost 3 times as much, and they're half as productive. So we're going to have a problem here that we're going to need to solve from a firm-wide standpoint. Okay, I'm going to pause here. So what we can see here is that as we generate our ISO cost curve, our original ISO cost curve, light blue line here, given our price of capital and workers, that if we were to change the two, instead of going from a wage rate of $24 to a wage rate of $8, that as workers become cheaper, right, the curve in some sense does become flatter, so at least the x-intercept is going to be further from the origin. But again, not surprisingly, what we would also see, given the minimizing cost rule, is that as workers become cheaper, the firm should shift production to use workers a bit more because they are cheaper. And obviously, we're still equating the marginal productivity of each dollar spent across the two inputs. So, when we put this all together here, is that, if we look at, and this is where it becomes even a bit more topical, but if we look at domestic production, if domestic production is more expensive for both the labor and capital, and the argument is then made that it would be cheaper to import the item, to have the laborers and the capital be abroad, that it's, in this case, let's say, half as much. The question would be is, if the firm manufactured abroad, will it change its amount of labor and capital? And what will happen to the cost? Well, so notice this. So if both of them, wage and capital, cost of capital, are half as much, the ratio itself is not going to be changing. So it will, right, in order to produce these items, we're not going to see any change in the fundamental ratio, right? So just going here, right, let's see here if it shows. No, it doesn't show it here, so never mind. So would the change in factor prices affect the slopes of the ISO quant or the ISO cost line? Well, it's not going to affect the slope of the ISO cost. It's just going to be, in this case now, further from the origin because it's going to be cheaper, right? So instead, you're going to have something that looks like this. Whereas the original line was here, doing it abroad is going to put the ISO cost out here, right? For the same amount of spending. Whereas let's say the budget here was, let's say, $1,000. Now the budget at 1,000 is going to be way out here. So really then what you're going to see is that you're either going to get one of two possible solutions. It's either going to be cheaper to produce the same quantity, or more stuff is going to be produced at the same cost. One of the two. And what this gives rise to then is starting to look at the expansion path. And the expansion path would give us a bit more detail about what's going on. And what it does is it finds all the cost minimizing combinations of the labor and capital for each input level. And that's what we see right here, right? That for each, if we try to trace out then all the optimal points for all the different budgetary levels, what we'd see is that a $2,000 cost, a $3,000 cost, and a $4,000 cost, that we are now further and further from the origin. And what we can do is we can, instead of having K and L on our X and Y axis, instead we can put the cost on the Y axis. And our expansion path, in essence, becomes our long run cost curve. And so when we look at these production functions, and we see that if it's locked into the idea that there's 1 unit of labor for 1 unit of capital to produce 1 unit of input, then the question becomes again, what happens when we change these number of inputs? When we expand them, what's going to happen to the production levels? Again, this idea of the doubling the costs, doubling your commitments to the inputs, are we getting double our outputs? Again, it's going to be related to this idea of where are we on that cost curve. And again, what we see is that the cost curve is not linear. Instead, it rises at a decreasing rate and then rises at an increasing rate. Again, reflecting the diminishing marginal productivity of the labor, with the average being brought down so long as the marginal cost curve is below it, and then the average cost curve being brought up to the extent that the marginal cost curve is above it. And what that brings us to then is one of our final parts of the topic here, which would be to talk about the economies of scale. And in the economies of scale, what we're talking about here is this idea of what's going to happen to our average cost of production as we're changing our output. In essence, it really becomes then a question of is bigger actually better? Well, it depends. It depends where we're at along the cost curve, and it depends what things look like. But in essence, what we see here that if we put our quantity of the output on the x-axis and we put just money or costs on the y-axis, that you can have a long-run average cost curve, LAC, that looks like this. And that the long-run average cost curve is actually enveloping a series of short-run average cost curves for all different production levels. And the question is, which short-run average total cost curve are we at? How big are we? If we're going from A to B by getting larger does in fact reduce costs. But if we're at C and D for those levels of production, then getting bigger actually raises costs. Which would be our diseconomies of scale region. So, in essence, we could imagine having economies of scale here and diseconomies of scale here. We could obviously graph that out. We could make a table with those costs existing based on our previous knowledge of what the cost curves look like. But this doesn't say anything different than what I just said. And here's a much better picture of it too. Now the question would be, why is this the case? Well, it would require, why this is the case is that for, again, certain types of industries, you just become cheaper as you become bigger. Um, uh, what's not necessarily always known by the firm is what this curve exactly looks like. And that's where we get this kind of application here, where we look at what that, in this case, what a beer manufacturer, again, I'm guessing so that they sound cool, is being a bigger beer manufacturer better, that it reduces costs. And it turns out, actually, his example of using beer isn't entirely to make himself seem cool. Um, the beer industry has actually consolidated quite a bit in the 2010s in an effort to reduce their costs more. And we've got this other idea here too, that we could make it so that it's a little bit more personal, and that would be whether a person should buy a laser printer or an inkjet printer, with this idea that if you're not printing a lot, an inkjet printer can be cheaper, but as you print more and more, then a laser printer is better, right? And so we as individuals face this, right? If I'm an old person, I might just start Ubering around because I'm not going to be driving as much as I am today, right? So we could look again at those short run average cost curves of transportation. And having my own vehicle is a pretty expensive way to drive around. But if you drive around enough, then the amount I pay per mile is going to be less than if I Ubered it all around. That's the kind of idea that's going on here. And we can then start to look at these expansion paths, again, to get an idea of should we expand or not. And in this case, we would have the suggestion here that costs are getting lower as we get larger. The final thing for this chapter, well, two things here, but so the penultimate thing here would be is that the other thing we need to look at is how costs change just because of learning by doing. That by getting experience, you do become more knowledgeable about things going on within the factory, and you thus become more productive and more efficient. Nice little side fact is that actually some of my earliest research back in the late 90s was on this human capital model of learning by doing. That's right, my previous life. And we see this learning by doing here. We can see this in chip manufacturing, for instance, with Intel. And this idea that as they produced more and more chips, they trained a whole set of workers and managers that became incredibly skilled at making those chips and making them cheaper. Until the early 2020s, right? Which at that point, then most of this work had happened overseas, specifically in Taiwan. And besides the economy of scale, then we also need to look at the economies of scope. And this is our final thing here. And what this does is this gets to the idea of whether it's more or less expensive to produce goods jointly than separately. And that's all going to be shaped by the nature of the cost curve itself. And again, it has obviously manufacturing implications here because it's going to affect how we organize our production and why firms decide to produce things in-house, and whether they decide to outsource things instead. Okay.